How are you doing, sir?
I'm doing good. How about you?
Excuse me. Sir, would you like us to upload the presentation or would you be sharing your screen, sir?
I will share my screen.
Okay, okay.
I will share my screen.
Yeah.
Only thing that I am trying to find now is where is the option to change my default audio. But yeah, I think I'll try to change it. Okay, I got it. 1 second. Able to hear me, madam?
Yes, yes, sir. Clear.
Okay.
Very clear.
This is clear. Okay, thank you. Yeah, I have it handy, madam. My presentation is available and handy, so I can share it. 1 second.
We'll let you know, sir. We'll let you know when you can share the screen. As of now, we'll have an introduction and then we'll proceed for the presentation, sir.
Sure, definitely, madam. Thank you.
Thank you, sir. Sir, we'll just start in another 2-3 minutes, sir. We are just waiting for more participants to join the session.
No problem, madam. No problem.
Thank you. Morning, sir.
Good morning, madam. I will just log off and log in again, madam, just for one minute.
Sure, sir. Sure. Thank you. Can we come in? Can we start?
ma'am?
Yes. Let's start. Good morning to the esteemed session speaker, delegates, participants. On behalf of all the members and the management, we would like to extend our warmest welcome to the first International Conference on Applied Mathematics, Modeling and Simulation in Engineering, AMSC 2021. We resume the conference keynote sessions today. It is my privilege to welcome Mr. Narasimha Rao Dattappa to the session. Welcome you, sir. I wish each and everyone a successful and fruitful conference. I now request Ms. Archia Tanveer ma'am to please introduce the keynote session speaker. Over to you, ma'am. Thank you.
Yeah, a very good morning to Mr. Narasimha Rao Dattappa, organizers, delegates, and all the participants. A very warm welcome to Mr. Narasimha Rao. I take honor to introduce Mr. Narasimha Rao to everyone here. Mr. Narasimha Rao is working as a Principal Software Architect, Center for Management Studies, Cantor, Hyderabad, India. Mr. Narasimha Rao has been working in the IT industry, specifically in software development for last 2 decades. He performed roles ranging from software developer to COE director. He has worked with several tech giants, namely Microsoft, IBM, Hitachi Consulting, Deloitte, and currently working as a principal software architect with one of the major research company, Cantor. An open group certified TOGAF architect, he holds cloud certification from Microsoft. He is also a certified Scrum Master. He has been working over a decade on Microsoft Cloud Azure from the day of its launch. He has equal level of comfort and knowledge on other cloud providers. An avid speaker on cloud computing, software architecture, applications design and development, software development best practices. He has delivered over 600 plus hours of technical sessions to both internal and external audiences. He has been the winner of several accolades within and outside the organization he has worked. Prominently, Mr. Narasimha Rao provided architecture for an application that has won first prize in DSCI Facebook Application Challenge. So you are most welcome, sir. Now Narasimha Rao is going to deliver a session on cloud computing opportunities for upcoming engineers. Please go ahead with the session, sir.
Sure, madam. Thank you so much for the warm welcome and the kind words. It's really a very very happy moment for me to do this session, especially connecting back with academia is something that I always love. And this is probably one way I could give back my knowledge of technology back to society. That's what I feel. How do I share my screen? Share your screen. There is one button here. Entire screen.
So you get more options.
Yeah, got it, madam. Thank you.
Okay, thank you.
All right, thanks. All right. So, firstly, thanks for the organizers, everyone who encouraged me to bring this session forward. One of the aspects that I generally see, or one of the common phenomena that I generally observe, is that especially in our country and specifically in cities like Bangalore, Hyderabad, we have very good, excellent, highly energetic engineers coming out of colleges every year, and then we see a lot of them making very good headway into the IT industry. A lot of them becoming entrepreneurs, startup owners, and one thing that I always felt is probably giving a little bit of idea around professionally what opportunities generally exist for these engineers. Now, here we are looking at cloud computing because most of the industry is now moving towards the cloud. Even if we look at today with regards to banks, which earlier had some sort of hesitation moving to cloud, now even banks are moving towards cloud. So while this session is focused around cloud, but the most of that what I'm going to speak is very generic, and you can apply it to day to day or any other roles within the IT industry. So my session has uh, broadly I've tried to classify into two sections. One is specifically focusing around what kind of job roles that exist because of the cloud boom. As I would say, for last 10 years, so many companies are moving towards cloud. So many vendors are coming and offering cloud services. When I say vendors, Microsoft, IBM, uh, Google, and Amazon, which is leading cloud provider. Now, what kind of jobs that are prevalent in the market primarily because of cloud technologies? Then the second part of my session will focus on for those enthusiasts or for those uh, engineers, enthusiasts who are a little bit more adventurous and want to do something on their own, or probably just want to try it as part of their final semester or third semester project. So the second part will give you how you can leverage cloud to do something that you always wanted to do uh, in the software. So that's the agenda, and we'll probably start with a basic definition. Unfortunately, there is no standardized definition for cloud. Companies offering cloud services have defined cloud in various ways. Here I have presented two definitions. One from Cloudflare, which I felt is more simpler. It just what it says is that cloud refers to servers that are accessed over internet and software and databases that run on those servers. These servers are located somewhere in the data centers. So if any one of us has a Google Drive account or the big blue button that we are using right now for this conference, or if we have used any emailing service, or if we have used OneDrive, we all know that those don't exist on our laptop. They are somewhere existing on the internet and somewhere else in some data center, and we are accessing them through the internet. We are connected to them through the internet, and we are able to leverage that service. If it is email, I'm able to send an email, I'm able to receive an email, respond to an existing email. So things like that. Or if it is about document services, I'm able to uh, upload my document, share with my friends securely so that it doesn't fall into the wrong hands. So these are all services we are able to do. And it is so easy. If I have to do the exactly the same thing through my laptop. Example, I have a shared drive in my laptop. I put all my files in that shared drive and I connect my laptop to internet. Even then I cannot share it with anyone. It is very difficult. There are so many probably there may be nowadays there are so many tools coming up, but it's not that easy, and secondly it is not very secure as well. and I need to keep my laptop on for hours and hours. It might get bogged up and it might come down someday. So in simplistic terms, if you are able to put your laptop or your desktop at home or in your college in a way that it is accessible through a browser, through a well-regulated software, then and you are able to switch on the services, switch off the services, able to access the database on that particular desktop or laptop, then you can say that you have also hosted a cloud environment. So cloud simply means that there is some hardware, there are a set of software that are existing somewhere in the internet, maintained by somebody else, to make sure that they don't get down, they don't uh, stop working, and for our benefit. Okay, somebody else is maintaining, and we are able to use. In simplistic terms, that is what is cloud. Now we will look at a simple scenario that will make it clear. Let's say you have something on the left side. I've tried to put all the items that 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 are relevant if you are doing something on your desktop or laptop or on premise, as we say, which is non-cloud environment. Now let's say we have a we want to develop a small application. I'm assuming most of the people attending this session are upcoming engineers, and my assumption for this session is that probably you don't know, probably you have not done any application so far. So I felt I should start from there. Hence, so those who have already done, maybe you can just pick up some key takeaways. But for those who have not done any application, maybe you can follow along. So let us say you want to build a small application. As an example, you are trying to build a photo or image upload application that recognizes the uploaded image. Think of this application. We have Instagram, we have so many other image sharing applications. We have social media applications that most of this generation must have used. To build such an application, what do you need? You need skills, which is, of course, is inevitable, whether it is cloud or non-cloud. The skills include the software, non-software aspect, which we'll cover in a moment from now. Then, in terms of purely the bare minimum necessities of hardware and infrastructure, what we need, you need a server wherein you need to install an operating system, connect that operating system to an internet, keep that server on forever, because people might access whenever they want. So you cannot put a timeline around it, say this server will work from 9 to 5. Then install all relevant necessities for your application to run, like a web server, like an application server, the language frameworks using which you might write the code, and then deploy the application and maintain the application on an ongoing basis. That's what happens and all this, everything has to be done by by the developers, by the network administrators, by anyone who is involved in this application development. Now, a part of this is true, but a lot of it is simplified when we go to cloud. With cloud, you'll simply go to a cloud provider like Microsoft Azure or Amazon Web Services or Google Cloud. You'll go, like like how you do with a simple email. How do you open an email? The same way, in the similar fashion, you are going to buy a subscription with a service provider, and you'll start using these services. So you don't need to set up any physical hardware. It's all done by somebody else somewhere. But then the question would be, how do you access it? You can access it simply through the browser. So if I may show you very quickly. So what all you need to do is that just get into the uh, get into a particular environment, and then just start using them. For many of you, this might not make sense for now, but just you can follow along and maybe explore it a bit later. And I have mentioned all the resources that are required for you to explore in my subsequent slide. See, this is, I just used the browser. See, you can see it. They say something virtual machine is there. There is a SQL database. You can start using all of them as if they are available to you in your own local environment, like how you use your server in your college network, or probably at the database on your machine. Now, is that all about the cloud? No, cloud is much more beyond that. It is not just about a hosting environment or providing hardware. With advent of cloud, what happens is that many people put their software in the form of APIs, application programming interfaces, such that others can consume them. And when others consume, they get little bit price. They need to pay a little bit price for that, or I can't say little bit. Probably it is based on the usage. They need to pay price for that, and they can leverage pre-existing, well-tested software. Now, what do I mean by that? Let us say in this scenario, you are uploading an image, and the application recognizes the uploaded image, maybe comparison of the image already uploaded, something like that. If you have to write that code, it probably takes loads and loads of time, and it drives you away from your core application. You need to now start writing code specifically for this. If somebody has already has written that code, and if it is available over internet, and if you can use it, why not? And by paying, I'll give you a very simple example. So here, let us see something that is provided by Microsoft. So here you can see this is something wherein this particular service, cloud service, is comparing two images. Now we are doing this through the browser, but actually this can be done through your code, because for us to quickly test and understand whether this is something we want or not, they have given an example here. So what he is doing is that allowing the user to upload two images and comparing the image in the frame. We can do that as well. Let us try to upload probably one of the Bollywood actors, that is Amitabh Bachchan. And then when we upload the second image, let's upload his latest image. See here at the bottom, it gives a confidence level to what extent, and it says the two faces belong to the same person. This is a quite complex software somebody has written, and you can use it by just subscribing to that service and paying. It reduces so much of effort and offloads so much of pain from you, so that you can develop your core application faster. No, we can, and probably if I put my photograph there, let's see, create upload. The two faces belong to different people. Confidence is 70%, I believe. This is a simplistic, probably very rudimentary example of how you can benefit from some of the existing cloud services. As I mentioned, some of you engineers who are more adventurous actually write software and host it on cloud and allow others to use. And then you can become entrepreneurs, wherein when somebody else uses software quite similar to the way we have used just now, so then then you can get some money for what you have done. Moving on to the first part of my presentation, what roles are available? I'll just step back and we can see I haven't mentioned one more role here, which is cyber security. I will cover that as well. Here, this is overtly generalized set of roles. Any role you might hear will fall into one of these buckets, definitely. And the skills that I'm going to show that will be presented along with these roles are sufficient enough to basically pursue any roles that are existing. So the roles include like application developers and testers, which is not probably massively greater than different than on-premise developers or testers, with subtle differences in the way or the kind of skills you might require, the way you code and the kind of skills required. I will cover that in my slide. Then we can see now for the last 6 to 8 years, a set of roles are evolving called data engineers, which in the past were called business intelligence developers. Now these data engineers are quite an evolving field. You might have heard about data science. So these are part of those technology groups or those domains that involve data science. Then this is the quite interesting one, DevOps engineer. Probably 15 years back, you would never have heard somebody by name DevOps. And as industry has evolved, this role has evolved. And with cloud, this has taken altogether a different dimension and created a new set of opportunities for engineers who love to work on code, at the same time who also love to work on the infrastructure part of the application, who don't want to work on the applications, who don't want to work creating screens, validating data, or who don't want to work on testing the applications by writing code, but who want to do coding to manage infrastructure like spinning up a machine with code, allowing certain users to access a particular application with code, and spinning up a machine and deploying the applications onto that machine with code. So that sort of roles have come up, and they are called DevOps engineers. This probably is, to be fair, not a very entry-level role, the cloud administrator, but there will be, there is a pathway. You can start as a cloud engineer and basic cloud and entry-level cloud administrator, and finally take on the full cloud administration role, which essentially is like in the past you would have a network administrator now, and that administrator would do on-premise network maintenance, whereas cloud administrator would do for the cloud service, but at the same time he would do some other additional set of responsibilities. So let's see that in a structured, well-defined way. Let me check if I'm on time. Okay, thank you. So the first role is application developers. Let's say someone wants to be a developer. Developers, whether it is cloud or whether they are targeting for cloud environment or non-cloud environment, they inevitably need to learn coding. Today internet has a lot of rating services wherein like if you go to Stack Overflow, it provides information around the most used languages. So one that appeals for you, you can pick up that language and learn to code. Most of the languages will have same set of constructs, and in most respects, the coding mechanism will be same. Today, even the editors we use to code are seemingly same. So there is only one editor, and you can code Python, Java, C#, JavaScript. So that is one of the advantage that is there right now. So coding is one of the main important tasks that developers will do. Now I have specified APIs or web services separately. It is no different coding. It is also a coding of API, but I want that to be very evident, because that is one of the key differences you will find when we talk about distributed programming, distributed development, or if you are targeting cloud development. As we have seen in our earlier example where we compared two images, somebody exposes their API, you will consume that API. So developer needs to know how to consume that API through their code. It is like a website. API is like a website, but without a HTML page. Okay, it allows you to call that API through a URL, http://something, compare photographs, take photograph 1, take photograph 2. So it allows you to pass the parameters as photographs, and it gives you result. But it is a different model of programming, needs slightly more more skills than the basic language skills, ability to maintain the state of an HTTP request and go back and read, because it is a fire and forget mechanism, like your email. If you have opened an email and so your laptop has the emails available, but it is not directly connected to the server. So if a new email arrives, nowadays the browser is refreshing them, but actually there is no direct connection. So how do you know what has happened to the request you sent earlier? That is the reason. The most, I believe, the important skill is the developers need to know how to call the APIs and leverage them. And for the more adventurous engineers, they can develop their own API. Now, developing your own API means, let us say, it could be about a basic, simple calculators, or it could be about a massive application like a Hyderabad map, or it is about integrating admission into your college, or exposing your college library to the outside world to consume the e-books available in your college, but you need to make sure that they have to be secured. And those are all the niche skills that one needs to possess if one is, and it is inevitable. It is inevitable, and someday all engineers who pursue a developer's career uh, on the cloud will be doing this, and it is better that you learn them before you venture out. Now, since I mentioned testers, probably a decade back, you would see testing happening more manually when people would open this screen. The testers, test engineers would open the screen, enter the data, and test the applications. It's no more the case. Majority of the applications, majority of the corporations now depend on automation testing. The right automation testers are no different from developers. At least in my teams, I don't treat them differently. In fact, they have those skills wherein they understand the unwritten part of it. Like, okay, I don't know how internally the application works, but I'm going to write probably these n mechanisms, n permutations and combinations to try and break this system. And all through automation. That is, I'll write code to test whether this application is working the way it is intended to be. To take a simplistic example, if you are writing an email service, the test engineers would log into the email in an automated fashion, compose an email in an automated fashion, check if the fonts and other formatting options in the emailing service are working as intended, and then finally able to check whether everything else works the way it is intended in an automated fashion. So they write code to check all this. Moving on, the skills required, of course, the basic coding skills. Then you can try out some of the front-end technologies. There are a lot of JavaScript frameworks that have come up in the recent past, the last 10 years. So be prepared with those to pursue these goals. Database skills are inevitable, and now with NoSQL databases wherein your data is not in the columns and rows format, it doesn't have a predefined schema. So learning at least one NoSQL database will be advantageous, and one need to know good knowledge of how web applications work, web services work, and application security concepts. How you'll secure your application from malicious users. Then lastly, at least knowledge on one cloud service. So in future slides, we will see how you can get that. Of course, your college curriculum might have some part of it, but which are much more fine-tuned and generic. But to get specific vendor kind of cloud services, I've given some resources here. Data engineers are quite similar to the application developers. They are no different. So they bring the data, they transform the data or manipulate the data in a format that is presentable and here we are talking about massive data. The earlier application developers, they were more about the screens, data entry by the users, validation, and then lot of ability to support lot and lots of users. Here we are talking about more of data. When you have an application, there is a lot of data that is created by that application. If you want to get a lot of insights from that data, a lot of reports, you want to study that data, that's what data engineers are helpful about. And this is the stepping stone, in my opinion, for the data science. So you have massive data, then you want to arrange the data in a form that you can visualize the data, you can see the data. That means you have to arrange them in a dashboard forms, in the report forms, or you want to explore the data, then you need to arrange the data in certain formats. So that's what data engineers do. And the skills they require are the extraction, transformation, and loading skills. Now it is slightly different. We are calling it as extraction, loading, and transformation. These data engineers need to know very good SQL, be it Oracle, be it Microsoft SQL Server, be it MySQL, the open source. You need to be able to write very good queries. So queries that are optimal, that perform very well, and are able to get all the data that the query is intended to do in a very efficient manner, means taking less and less of server resources. So writing good queries, beginner level knowledge on some of these visualization tools. Unfortunately, I don't know any open source, so I mentioned only proprietary ones. Power BI is owned by Microsoft. Tableau is owned by Tableau, if I'm not wrong. ClickView is another visualization service. So these are all, you can say, kind of reporting tools. You will get data in them. You can put them in nice graphical format and explore the data. Then, quite similar to the application developer, a data engineer also needs to know, have knowledge about the any of the or if possible all of the cloud services like AWS, Azure, or Google Cloud. Moving on, the DevOps one. This is the most interesting one, as I mentioned earlier. So the DevOps engineers automate the deployment. So they need to write code to first compile the application written by the data engineers or application engineers, deploy that onto the servers, okay, and then make sure that everything is working. They need to also monitor. Now, a large part of this has to be done through automation. So I mentioned some of the technologies here. So here is what they have to do, and then uh, they need to know something like Bash, PowerShell scripting. This mostly something that people do on the job as a learning, but if this can be done and prepared, then you will be prepared for the market. One thing that is very important in general, I see the fresh engineers lack is version control and configuration management. Lot of developers write code. So generally there won't be one developer in a team. There will be lots and lots of developers. One key difference between what skill that DevOps engineer needs to know from other engineers is version control. If 5 developers are writing code, then where do they put that code? Okay, and how this code can be merged, then compiled. That is point one. Point two, when this code is deployed, how we will see a difference between the deployed code and upcoming code. That is the versioning. So this knowledge is something, if you can inculcate right from the beginning of your coding life, then it makes easy for you to move to DevOps engineering role. DevOps engineer needs to know some of the monitoring aspects. I haven't written any specifics here because each vendor like Amazon Web Service, Azure, or Google have their own specific DevOps tools. So, but the generic skills that are required, I mentioned here. Moving on. Cloud administrators, these are they they are like as the term says, the administrator, as the manager of that environment, they may manage the who will access this cloud, who will use this cloud, how we will make sure that incorrect people are not accessing, how we will make sure that all the people who are accessing this cloud are accessing the cloud within the costs that organization can sustain. Organization may have some policies like somebody cannot upload large video files. So how they will ensure these all things are done by cloud administrators. As I mentioned at the beginning, this probably is not an entry level role, but some of the infrastructure engineers will slowly graduate to cloud administrators. So a thorough knowledge of networking, which is understanding firewalls, understanding virtual private networks, wide area networks, is all required to become cloud administrators. They probably 5 or 6 years in a basic administration role or or an entry level infrastructure engineer role will take any engineer to a cloud administrator roles. Unfortunately, with this new normal of presentation, I can't say I will stop here and I will ask questions, but feel free to post, find me on LinkedIn and add me and ask any questions if you have, or I share those through the moderators of this session, and I'm more than happy to address them as and when my time permits. Now, the second part of my session, that's what I wanted to talk, was about the new way of development. The traditional way was wherein you would buy a laptop or you would buy a desktop, then you will install all the software. Think of a scenario that you think is not available, or you can think about a mobile app, or you can think about a web application, a website, and start developing. But then you have the challenge of hosting that if it is a website, and sharing it to your friends if it is a web app. Of course, you can share it if it's a Android app, you can put it on the Play Store, App Store if it is a iPhone app. Microsoft has long gone out of this market, so they don't have any. I don't know if Microsoft Store is still prevalent, but yeah, they had one in the past. Now, the other part of the challenges include, let's say if your application is quite a hit, which I hope, and more people want to use it. The hardware that you might use, whether your laptop or desktop, can it really sustain those many users accessing it constantly? With the modern world that is last 5 to 10 years, the speed with which people are developing the applications, can you really develop your application so fast? I'm not talking about the skills or individual capability that can you code in Java your application fast. No, you can, maybe you are good at writing your code very fast, but can you write a image recognition? Can you write a document management? Can you write a document sharing so much fast? No, it is not possible to write probably in 3 months or 6 months, because it is not just about coding, it is about testing it, well testing it, ensuring it, the security, ensuring that a lot of people are able to access it faster, right? So if you want to get that speed of development, then cloud is the best way to go. But you may ask me, how do I know where to go and where do I access the cloud? Here I have given two links. I would urge and request the um, facilitators or moderators of this presentation to kindly share this with all the audience, upcoming engineers, and all the interested participants.
Yes.
Yeah, sure. So these links will take you to those uh, places wherein the vendors are giving subscriptions to students. That is, Azure, Microsoft is giving Azure to students. AWS is giving it for students. But just in case, if you are using credit card, be really careful about how much, what services you use and how much it charges. And also when the subscriptions expire, free expires, and then it starts charging. But then the second challenge you may have is, how do you uh, start learning? You have the tool, but how do you learn? Every vendor, it's they're not doing any charity. They are doing it for their own, uh, I would say, benefit. Is they have this labs. Google and Amazon have something called Quick Labs. You can go and practice there. Microsoft has something, Microsoft Learn. They have the step-by-step guidance. Okay, how do you use a specific service? If you want to, in your scenario, when we say if you want to do an application, so how do you create an application, probably an ASP.NET or a Java application, and then move it to cloud? How to do it step by step? That all guidance is available. I have kind of given a case study or a simple application which covers majority of the services that that anyone who wants to explore cloud needs to know. Something like an alumni application, uploading photograph. Photograph is a file. You don't want to store in database. You want to store it in a file store mechanism. So that gives a opportunity for young developers to explore where I should store files on the cloud. Like Azure, you have a blob store. In Amazon, you have something called EC2. Then something like a rating mechanism. If somebody is posting their achievement, somebody wants to rate it. If you give rating, then the calculation and machine learning or something like that. You have services for all this. I've given here a simple uh, um scenario or a simple application. I'm sure you folks can think much more better scenarios than what I have presented here, and can use the learning resources that I mentioned in the subsequent slides and try to achieve what I mentioned as a new way of development. You try build an application, host it on the cloud, first test it on your local laptop, then host it on the cloud, leverage the existing services on the cloud like image recognition, like language understanding, like text processing, and then get the speed of development. Ensure that the hardware and software resources are are utilized efficiently by monitoring them on the cloud, then finally understanding if they are performing well or not. With that, I conclude this presentation. I wish all the upcoming engineers and all those enthusiasts all the best. There are a plethora of opportunities that are opening because of cloud computing and latest technologies. There is no dearth of jobs, roles, but what you need to bring in is a clear understanding of this. Nobody expects a newbie to be an expert, but if you can present a clear understanding of what the skills that we spoke earlier, I'm sure they would easily get you or land you in a good job. All the best. Once again, I thank the management. I thank everyone who has helped me bringing this presentation forward. I'm open to any feedback to improve this presentation if I do it in future. I'm open to any questions. So find ways wherein you can reach me either to LinkedIn or through my email and share your question. I'll be more than happy to answer them. Thank you.
Thank you, sir. Thank you for sharing the information with us on cloud computing. I request Asya ma'am to please summarize the sir's session lecture. Thank you.
Yes, sir. Yes, ma'am. Thank you. Okay, so cloud is the best way to go. Well said by Dr. Narasimha Rao. Thank you very much, sir, for sharing your immense knowledge, expertise, and views on cloud computing. And it was a wonderful and enlightening session on cloud computing. It will be definitely helping the upcoming to take the advantage from your session. And thank you for making this event a great grand event. We appreciate having explained these enigmatic areas of cloud computing and its application in a simpler way. So you explained it very well, sir. If you allow, we would like to invite you to answer a few questions on this segment, sir.
Of course, madam. I'd love to take some questions, please.
So we have a few queries posted on the YouTube. I'm
Sure.
going to post it in the BBB chat screen for your reference. Some questions are there on the screen. So the question asked by the students here is, why is Azure Diagnostic API needed? Is this a relevant question, sir?
Yeah, diagnostic API. Yeah, that, I mean, irrespective of its relevance, a diagnostic API is needed because you want to see how your application is performing. Diagnostic API is where you plug your, let's say you have written your own application and you want to also capture the application performance metrics, right? I mean, how is it spiking, whether what is happening with the application, and then you want to take remedial tasks. That's where the diagnostic APIs means. See, this is a third. This is maintained by somebody else. Means it is there in the data center, external to your access. So what is happening when your application is running on the server? What kind of uh, memory captures are happening? What kind of disk access is happening? So those all things you can get through the diagnostics API.
Okay, and the next question here is, What is required to do when your drive failure occurs? I don't know whether.
No, that's fine. So, drive failure happens. See, drive failure is what you will avoid by going to the cloud. Every cloud provider gives you a certain level of SLA, service level agreement, right?
Yes, yes.
So they will say that we are going to make sure that your data is safe up till 99.95%, or we will ensure that the failures are probably 0.0005%, something like that. So if you go to the cloud, first thing is that you are depending on the technology bigs like Amazon or Microsoft. So which will ensure that the failures don't happen. But if they do happen, then there are mechanisms to recover, which is something beyond beyond the reach of the cloud consumer. It is taken care by the provider themselves, like Azure or Amazon or Google.
Right. So next question popping up here is, what's the best Azure solution for executing the code without a server?
Right. So if you have already have done some programming on Azure, then in general, if you are taking whatever you have written on premise on your laptop and want to shift everything onto the cloud, the first thing that you will do is you will use a virtual machine, which is almost a mirror of your laptop or desktop on your code. That is the first part. The second part is, if it is a web application, then you will move it to something like a web app or web service. The third one, if I get this question correctly, is serverless computing. Is like you don't use a uh, web server, you don't use a application server. You directly use something called serverless computing technologies like function apps in Azure or Lambda services on the AWS, wherein whatever you are writing, it just executes only that piece of code separately without really using the broad application services or the broad application server resources or web server resources. So you are abstracted from that. Only you can you can run only that piece of code as a serverless function or a serverless piece. I hope that answers the question. But if you want to explore more, then it is Lambda on the AWS and Azure functions on the Azure. So they are both competing technologies from different vendors, but that's how you achieve the serverless. Yeah.
Okay, thank you very much, sir, for answering these questions.
No.
One more question. Like, she wants to know whether where can links for technical sessions for paper presentations. Someone wants to know that.
Perfect. So that's actually good. All the questions I really appreciate. Some of them have been from, I believe, from folks who have already explored some part of cloud, and this probably is for someone who wants to learn. I've given links, the quick labs, in my presentation. Please share it with all the participants. So that has links. One suggestion that I have is, first try out one service provider, and uh, then you will actually get to know that other service providers are just same. Each service provider has given significant set of resources, learning resources. You don't need to really spend time on YouTube, because YouTube will have diverse set of information, and it may not be in a structured way. Once you get understanding of a particular technology, then reach out to YouTube. But to start with, if it is Azure, use Microsoft Learn. That is the site, learn.microsoft.com or docs.microsoft.com. I've given that in the presentation. That's the place to go, and they have a path. They will give you a very clear path as to how to start learning these technologies. So, if I may, then just 1 second, very quickly, I will share. So, if I'm not sure if this is getting shared. Yeah, it's coming up, I believe. All right. So here, this is learn.microsoft.com. Probably I'm a little biased towards Microsoft. That's the reason I keep coming back. But I would highly encourage you, everyone, to really be very generic, whether it's AWS or Microsoft. You have these resources. So go to this learn docs.microsoft.com. Learn. If you simply type Microsoft Learn, you will land here. Because I've selected something, it is showing me this particular flow. But otherwise, it will ask you what is the role you want to do, and then it will suggest some set of sessions for you. And these are very good. These are very step by step, neatly and nicely organized. So I would highly encourage using that rather than generic resources on the web, or even going to a outside training session.
Right, sir, right. So thank you for illustrating and showing how to do that, sir. That's very nice of you. Thank you very much, sir. So in today's session, actually, I'm not from the same background, but I tend to understand some of the few of the applications of the cloud computing. So you explained it very well.
Thank you.
Very patiently, you have explained one by one with a very systematic manner. You have explained that, sir. So I was about to understand actually what is cloud computing. So we explained the roles in different applications in the field of cloud computing, under which you illustrated examples of facial recognition, in which you have given the example of Amitabh Bachchan. That made the session more interesting for the viewers. So we are very excited to learn about the new thing in such a interesting manner, sir. Then you highlighted on the new ways of developing software or innovating ideas. Then you gave an insight on something about Azure cloud services. Uh, so then taking out the session, you also talked about the speed of development, the cost-effective hardware and software resources, and then high-performing applications. So you have touched every area of cloud computing, and you have explained it very well to all of us so that we can understand your insight on the cloud computing, sir. Thank you very much. Now I
Thank
get
you.
over to Udayani ma'am, if she has
Thank you,
conclude
ma'am.
the session.
Thank you. Thank you,
Thank you.
Archia, ma'am. Thank you
Welcome.
for raising Mr. Narasimharao Dattapa's session, lecture on cloud computing, the opportunities for upcoming engineers. So it was a very nice overview of what are the different opportunities. And one primary question normally we have is what is the difference between data scientists and data engineers? So can you just highlight one or 2 points about that? Data
So,
engineers, data scientists.
very good and very valid question, and it is. So let us probably think about this COVID situation, and if we take COVID situation, we today there is a necessity to predict whether we can send our kids or whether we can start the colleges and ask students to come to the colleges. I'm not sure if that is a very popular topic, but I'm just taking as an example. So if we want to predict that, and if we want to see what probably could happen down the lane, 1 month from now. So here are the things that people will do. we will take all the past 1.5 year data from the COVID time last, from the 2020 March data, and we need to study the trends. Now, who will do that? If as a software developer, what my role would be is to get all the data from various different sources into a particular database or into a common location. That is a data engineer's role. Data engineer will get the data from WHO, from Indian government, from probably whichever source you can get the COVID data. Then what we will do with that data? There will be statisticians, okay, who know what statistical models need to be applied to that data to get the predictions. Data engineers who are probably from the developers background, who are software engineers who understand software, may not know statistics as much as a statistician knows, and statistician may not know as much of data gathering technologies that a data engineer knows. So a data engineer, to put it probably in a simplistic way, data engineer writes code to get or pull the data from various different sources and put it at a place and in a model, in a way that statisticians can understand. And what statisticians do is that they apply these statistical models on top of this data to provide insights or to provide predictions. Here, the second part, these statisticians are none other than the data scientists. But then how is every statistician is data scientist? Probably not. What happens is that a data scientist is slightly bit more technical, in my opinion, than a regular statistician. In no way a regular statistician is less. The only thing is that with the newer roles coming up, the statisticians who use tools like Python, who use tools like R, and several other this statistical modeling technologies, and analyze the data and provide the facts, provide the predictions, right? They are called data scientists.
So more the person who actually studies the data would be more like a data scientist.
Correct. Who studies and provides inferences from the data is a data scientist.
Okay. So actually, I know you're spending more time than we have scheduled, but there are two questions that have popped up. Someone wants a brief overview of the continuous integration process, CI process.
Continuous integration, yeah. Continuous integration is a very interesting and important aspect of today's software development. We need to step back and think about the software development life cycle itself when we are talking about continuous integration. We first analyze the requirement, design the application, develop the application, then deploy the application, then test the application, and then release it to the users. But then when users are using the application, we may face some issues. At the same time, we may want to add newer features. Most of us, almost every one of us are using mobile phones. Every one of us, we are using so many applications on the web nowadays, be it social media applications like YouTube or Facebook or Twitter, or shopping applications like or e-business applications or e-commerce applications like Amazon. So these applications, they deploy, they do the changes and deploy probably every minute. If we take Facebook or Amazon, I think Amazon deploys multiple times in 1 minute. So how is that deployment so fast? What they do is that they automate the entire deployment process. Is it about simply compiling the code and deploying it to the server? If it is one server, a simple machine, then this process is probably very trivial, very easy. But if it is about massive number of servers, like 100 servers, 1,000 servers, then deployment cannot be done by an individual. That's where this deployment is automated. That is only first part of the second part of the continuous integration, which we call as continuous deployment. Integration is where multiple developers are working on the code. So all the code has to be merged, and then this merged code has to be compiled. The compiled code has to be deployed at some place. You cannot directly deploy the code written by developers onto the server. That code has to run through the tests. So the automated tests have to be fired. Now this automated tests run on the compiled code, and when they run on the compiled code, if something is failing, that needs to be notified back to the team which has done this development. Okay. And then if everything works fine, then this compiled code that is deployed, then on which the tests are run, have to be deployed to the servers. This entire process of the code going from a developer's environment to the production environment by getting integrated, by getting tested, is the continuous integration and continuous deployment process. And that's what is one of the key goals or key responsibility of a DevOps engineer. It is a topic in itself, probably needs at least an hour to really go through a step-by-step mechanism to explain why it is required, what problems it solves, and what mechanisms are available to achieve it. But I try to explain it is in a nutshell.
Yes, we understand that. I think that is one of the reasons they have asked a brief overview of the continuous integration process. So, thank you, sir, for the elaborate description and explanation of every question.
No
Thank you
problem.
so much. And we wholeheartedly welcome you to continue to be a part of our keynote session. We have one coming up in the afternoon, sir, by
Definitely.
Dr. Anand Nair on future smart transportation systems. So you're the most welcome to join us during that time. And also we have the valedictory commencing at 3:45 p.m., sir. So, please do join us. We would be very happy to have you in the valedictory also. Thank you so much, sir.
Will do, madam. Thank you so much.
Sure. And sir, a letter of appreciation will be emailed to you from the team. Please do accept the appreciation.
Definitely, madam. Thank you so much.
Sure, sir. And we would appreciate it if you could give us a testimonial to that effect, like how your experience was with the team and the overall conference, sir.
I will do, madam. Thank you.
Thank you so much, sir.
Have a good day, madam. Thank you. Bye-bye.
Thank you. Same to you, sir. Dear participants and delegates, we will resume the conference keynote sessions at 3 o'clock. By the session would be by Dr. Anand Nair on future smart transportation systems. So please do join us at that time and stay tuned. And also, I extend an invitation to all of you to please join us for the valedictory function after Dr. Anand Nair's lecture. Thank you. Please stay tuned. Thank you. Have a good day.
Audio Jungle. Audio Jungle. Audio Jungle.
Good afternoon, Dr. Anand Nair, sir.
Good afternoon, ma'am. How are you?
Good, good. Thank you, sir. How are you doing?
Yeah, fine, ma'am. Fine.
We'll start in a minute, sir.
No problem, madam.
We're very happy to have you, sir.
Same here, ma'am. Real honor to be the part of this.
Thank you. Good afternoon to all. Good afternoon to the distinguished keynote session speaker, delegates, participants. On behalf of all the members and the management, we would like to extend our warmest welcome to the first international conference on applied mathematics, modeling, and simulation in engineering, AMSC 2021. We resume the conference keynote afternoon session now. It is my honor to welcome Dr. Anand Nair to the session. Welcome, sir. I now
Thank you.
request Mrs. P. Prasanna to please introduce the keynote session speaker. Over to you, ma'am. Thank you.
Thank you, ma'am. Good afternoon, sir. I am T. Prasanna, working as assistant professor in a EC department, Stanley College of Engineering and Technology from it is my privilege to introduce you, sir. Dr. Anand Nair, sir, received PhD in computer science from Deshbhagat University in 2017 in the area of wireless sensor networks and swarm intelligence. He is currently working in School of Computer Science, Dutan University, Da Nang, Vietnam. A certified professional with 75 plus professional certificates from Cisco, Microsoft, Oracle, Google, BeingCert, Exim, GAQM, Cyberom, and many more. Published more than 100 plus research papers in various high quality ISI, SCI, SCIE, SSCI impact factor journals. 50 plus papers in international conferences indexed with Springer, IEEE Explore, and ACM Digital Library. 40 plus book chapters in various Scopus, Web of Science index books with Springer, CRC Press elsewhere, and many more. Member of more than 50 plus associations as senior and life member, including IEEE and ACM. He has authored, co-authored, edited 50 plus books of computer science, associated with more than 500 plus international conferences as program chief, board, review board member. He has 10 Australian patents, 2 Indian patents, and 1 Indian guide to his credit in the area of wireless communications, artificial intelligence, cloud computing, IoT, and image processing. Awarded 30 plus awards for teaching and research, Young Scientist, Best Scientist, Young Researcher Award, Outstanding Researcher Award, Excellence in Teaching, and many more. He is acting as associate editor for Wireless Networks, Springer, Computer Communications Elsewhere, Frontiers in Computer Science, IET Quantum Communications, IET Wireless Sensor Systems, IET Networks, IJDST, IJISP, IJCINI. He is acting as editor-in-chief of IGA Global, USA Journal titled International Journal of Smart Vehicles, Smart Transportation Systems. He has reviewed more than 1,400 articles for various Web of Science Index journals. He is currently researching in the area of wireless sensor networks, IoT, swarm intelligence, cloud computing, artificial intelligence, drones, blockchain, cybersecurity, network simulation, and wireless communications. With Google Scholar citations, 3,750 plus, H-index 32, and I-index 108. I welcome you, sir, and it is our pleasure to have you here, sir. Thank you very much, and please continue for the session, sir. Thank you.
Madam, tell me how can I share my screen, please?
Yes, sir. We'll be giving you the presenter right.
Madam, can you tell me how to share the screen, please?
Sir, can you hear me?
Yes,
Can you
ma'am.
hear me? Yes, sir. Sir, just a second. We are giving you the presentation right, sir, so that you can see a button at the bottom of the screen.
Yeah, sure.
Radhika, ma'am?
Yeah, of course, ma'am. I got the button.
Yes, yes, yes. Okay. So
Just
you have
wait.
to click that button, sir, and you should be able to share your screen. Yes, sir.
Yeah, just wait, ma'am. Madam, can you see the presentation?
Yes, sir. Yes, sir.
And is my voice clear?
Yes, crystal clear, sir. Thank you.
Okay, perfectly. Thank you. So, good afternoon, ladies and gentlemen. I'm Dr. Anand Nair, and I'm working as professor, researcher, and scientist in graduate school, Dutan University, Da Nang, Vietnam. And today, in this international conference, it's a real honor that I've been invited as keynote speaker. So, I will be discussing in depth with regard to Internet of Vehicles. And you can see that this is one of the, again, narrow concept, and you can say a high-end concept derived from Internet of Things or Internet of Everything-based ecosystem. So what the future transportation systems will look like and what will be the architecture and what are the research guidelines, I will be talking about everything in depth in this lecture. So the agenda for the talk will be very simple, that I will be discussing a brief introduction towards Internet of Things or Internet of Everything. And after that, we will be discussing regarding the future infrastructure for the Internet of Things, what exactly will be the infrastructure that will lay a foundation that how our autonomous vehicles and Internet of Vehicles will become the part of sustainable cities or the hyper mega intelligent cities of the near future. After that, I will be discussing in depth with regard to the connected vehicle and intelligent transportation, followed by enabling technologies. And we will be concluding the lecture with a conclusion and followed by your question answer session. So everybody, let's start with the lecture on discussing in depth with regard to what exactly is meant by Internet of Things or Internet of Everything. Now, everybody, we are living in 2021 and everything is becoming connected, smart, and of course, it can be controlled from anywhere and everywhere. Consider your smartphones, consider smart buildings, smart agriculture, and of course, the wireless connectivity that is empowering everything to come under single roof. So you can see that Internet of Everything is actually changing the word for a better word. So you can see that we find some confusions with regard to tons of technologies today, like IoT, machine to machine, you can say interactions, cyber physical systems, intelligent systems, connected devices. They all are becoming you can say a plethora ecosystem and becoming the part of Internet of Everything. And you can see that by 2022, this industry can even lead to 14.4 trillion US dollars. So you can say that in the future, everything that will be becoming a part of Internet of Everything. So if you really want to research in this ecosystem, I would like to request you, rather than to research and focus on IoT today, we should focus more on Internet of Everything. And in the near future, we can even have, that is, bring your own Internet of Everything, even customized Internet of Everything. So which means the architectures as well as the driven models will be changing and taking the new faces. And that is what you can say if you talk of really complexity environment, hyper dynamic environment, and the environment which is radically changing and changing the face of the mankind. Vehicle transportation and future transportation is one of the important things, because as you know that today's cities have different faces, they have different requirements. Some cities have tons of transportation, but some cities have less transportation. So you can say that Internet of Everything will provide a new types of architectures and building models that can reshape the transportation like never before. And IOV is one of the, you can say, confined areas that we need to study and undergo our research. So Internet of Things or everything is, you can say it is a convergent evolution of IP and mobile networks. Now imagine everybody, if you talk of a connected car, it consists of plethora of technologies, like in terms of sensors, in terms of radar, lidar. Of course, we need some night vision cameras, and of course the power of artificial intelligence in terms of object detection, recognition, and tons of features. So that's the reason this connected car requires plethora of connectivity, and that connectivity can only be blessed when we are talking of next generation wireless communication standards like LoRa communication, dash 7, and we can even talk of 5G plus or even 6G. So you can say that in terms of connectivity, as you can see, of laptops, mobile phone devices like tablets, smartphones, and of course our sensors in smart homes, mobile internet, voices, they are all coming together and they are making up an ecosystem on convergence for enterprises, service provider, and data centers. And we can even see that this ecosystem can make up a IoT computer. And believe me, everybody, you will all agree with me that the futuristic communication technology or intelligent computing has tons of the requirement of computing power, which is not possible for today's mainframes and even today's supercomputers. And that's the reason we need to push up our limits towards quantum computers. Because if you talk of connectivity, the number of sensors and the number of devices, they will become 20, 40, and even 80 times more as we are living and seeing in 2021. And that is going to increase like anything. And that's the reason we can say that these markets are highly expandable, scalable, and of course flexible. So you can see that in terms of Internet of Everything, we have the broad set of applications that you can imagine. So whether it's a defense network, smart grids, even we talk of enhanced safety, smart city, agriculture, transportation, and connected vehicles. Even if we talk of the future universities, we can all imagine everything start from IoT and even ending at IoT. And it is convergence of technologies that will drive the, you can say, the activities, the hyper intelligence, and even communications. So you can say that but today IoT and IoE is playing a crucial role, and everything will be self-dependent on these technologies in coming next 2 or 3 years. So now you all know what exactly is meant by IoT or IoE and what exactly is the importance of IoE in today's and in the futuristic connected world. Now let us discuss something with regard to the broad application area. Like we talk of IoT, we talk of smart homes, smart grids, even we talk of ocean IoT today, even we talk of space technology. But I would like to focus today on Internet of Vehicles. So before we discuss that, we should understand that this type of technology is not possible even if you have a very good infrastructure, but it requires a next level of infrastructure that needs to be planned. So consider everybody that if you really talk of the futuristic smart cities, the most important thing will be the back-end infrastructure and of course communication standards. And if these are not okay, you can't derive the broad set of applications at the front end. So you can see that this is one of the common IoE architecture, which is actually proposed by me. And even we are doing lots of works in this area in terms of vehicular cloud, in terms of the future smart city and sustainable homes, and of course, sustainable agriculture version 5.0. So you can see that at the low level, like we have the physical layer in networks, in network communications, it starts with embedded systems and sensors. So for the sensors, it depends on the options and the application area that you are working, whether it is your agriculture, building, environment monitoring, industrial monitoring, or even if you talk of a simple monitoring based underwater or even military based battlegrounds. So they are all connected with embedded systems. And today we have Raspberry Pi, Leti Panda, we have Asus Tinkerboard, we have a Jetson Nano. Tons of embedded systems are even having AI functionalities that can provide tons of options and even provide big data analytics, predictive analysis, and even connected to the cloud. So after that, the most important is the field area network, in which we have to provide the multi-services in performance of edge. We are talking of fog and edge computing combined together because the data will be in the motion and we need to process that data at a regular fast interval in real time. And of course, after that, we require a mega connectivity of options in terms of routers, in terms of security, and of course, a high state-of-the-art packet switch network. And at the back end, we are moving towards data centers. So you can see now in this one, you can see that the embedded sensors are forming endpoint intelligence, followed by distributed intelligence, that is known as fog computing. And of course, after that, it takes the next level when we add cloud computing, edge computing, and of course, when the things become more and more better with connected devices like robotics, cyber-physical systems, these things become more edgiest. And at the last level, we talk of centralized intelligence, in which we will be using our quantum computers in the near future for providing tons of support for multi-level cloud servers or hybrid community clouds. So you can see that in terms of applications, we have network data, security in data, we require intrusion detection, sensor monitoring, network management. Of course, we have tons of applications in terms of monitoring, healthcare, surveillance. Everything will come around under this distributed data management and this type of ecosystem-based architecture. So everybody, you can see from this diagram that you can see that we are moving from peer-to-peer endpoints, and these endpoints are taking a close look towards fog and cloud. And of course, we are moving upwards towards the endpoints. So you can see, and this will make a sense that in the near future, the requirement for the infrastructure will become even 10 times. So imagine everybody, if we are talking of large data farms today, now imagine if we talk of autonomous vehicles, we talk of agriculture 5.0, bridging up society 5.0, sustainable computing and space technology with hyper-driven megacities. Imagine how much data is generated in just 1 minute. So you can say that the data will become so exhaustive that we require advanced AI to process and to predict and to make decisions from that data. So this is an example that you can see of the connected vehicles or the futuristic IOV, and you can see that the sensors are there on the roads and even on the street lights, and all the cars are having plethora of sensors, of course, radar, lidar connected to them, and this is all giving the data towards multi-edge connectivity network of 5G or 6G that is providing fog computing. And that's the reason, everybody, fog computing is required, because we are not talking of data at rest, we are talking of data in motion. And of course, all these applications will be providing with SDN network management. And at the back end, we will be having some applications connected to our desktops or even our mobile apps. So now, everybody, we will be discussing about intelligent transportation and the connected vehicle, the most favorite part of mine. And believe me, I am researching in this area from last 1.5 years, and we have published 6 SCA papers. And really, our most important thing will be that in the near future, I want to make my own car, which is already in development progress in my lab. And this type of cars will be able to match up the conditions, like complex conditions like of storm, hail, snowfalls, and even rainfalls in night vision. And they will be able to detect the pedestrians with their advanced AI and sensor-based object recognition and detection technology. So this is going to be a near future, everybody, and in front of you. And you can see that there will be almost everything working autonomously. So if we talk of today's shopping malls, Amazon has even made a shopping mall that is having no employees. And even if you talk of Japan, there are lots of hotels and even restaurants without even having a single employee there. So you can say that these type of things are enabling us towards intelligent transportation. Like you can talk of adaptive cruise control, like lane detection, vehicle to vehicle communication, vehicle to safety recognition, mobile phone communications, satellite using Starlinks, and of course, we have the travel assistance and vehicle infotainments. And this is going to be the key verticals for all of you. And you can see that the cars will be using V2V. And today, if you really want to study over there, you can see the standard that is IEEE 802.11p. And they are using 5.9 gigahertz of unlicensed spectrum. And all this is moving towards tons of infrastructure services like Wi-Fi offload, DSRC, consumer network. And this is all connected to the fog and clouds using policy enforcement, the DPI. And at the back end, again, time, we will be having our public clouds, private clouds, and enterprise clouds. So even I'm doing my research and writing the next paper that how we can have an end-to-end connectivity of the data with complete privacy. And over there, we are not working on IDS, we are working on blockchain technology. So blockchain will provide even with SHA 256-bit security, which right now with even supercomputer, the security, you can say cracking will not be possible. You just need a quantum computer. So which means that if we implement blockchain technology for Internet of Everything based, you can say hyper communicated network of vehicle to vehicle communication, we are talking of the most secured and the most advanced secure network in the planet. So you can see that this type of evolution will be possible with tons of connectivity towards fog, cloud, and of course with web. And we can say that in the near future, these type of cars will play a crucial role in order to have autonomous calibration with level 4 and of course with level 5, when we will not have even the brake, even the clutch, and even the steering wheel in the vehicle. Everything will be done autonomously with a neural computing software brain powered by advanced explainable artificial intelligence. So this is going to be an eye-opening thought for all of you. You can see right now that this is known as vehicle internals, which is having swarm of sensors. Like you can see road condition sensor, magnetic sensor, collision detection sensor, head-up displays, airbags, GPS sensor, air pressure sensor. So which means that more than 35 different varieties of sensors will be attached to the car. So even that is a reason we can say that tomorrow's autonomous vehicles or this type of connected cars or even electric cars of today, they are not talk of transportation. We can even talk them as a cyber physical system. So that's the reason, everybody, that if you really want to work today in this type of area, you must work on cyber physical system. So you can see my latest book with Springer, that is Emergence of Cyber Physical Systems on IoT as well as robotics, in which we have depthly covered all these aspects of the connected cars. So this is the traditional ECU topology, and you can see that we just have a OBD DLC connector connected with instrument cluster, and we have tons of options in terms of like Android Auto, Apple Smart automobiles. But in the near future, Google and Apple and even Microsoft, they are working very hard to make this ecosystem the most secure ecosystem, and of course with level 4 automation. Right now we are living in 2021, so level 3 automation as per DSRC is possible, and level 4 automation means that the car will be almost taking all the controls in its own hands, 80%. But we are talking of level 5 automation that will still require more work in neural computing, artificial intelligence, sensors, and of course development of software brain with the integration of blockchain technology for security. So these type of things will take some more time. And this is the integrated future vehicle network, everybody, and you can see that everything becomes super connected. So I'm not talking of a connectivity or intelligent devices, I'm talking of super connectivity. So in super connectivity, all types of sensors, radar, lidar, they are connected to one type of gateway, and those gateways will be empowered using 6G. And at the back end, we will have the advanced community data centers that will be able to transmit the data and help the car to foresee and make the decisions in real time. So this is with the ECU consolidation and virtualization. And in the near future, everybody, I would like to tell you that even Tesla and Nikola, they are making up trucks. So those trucks don't need to be present with a driver. Driver can just be at the home with a computer, and they can use their steering wheel or controls at the computer. And in the real time with 5G connectivity, the truck can take the controls. So in the near future, everybody, I'm saying you openly right now, note my words in 2021, that the future of cars will not be with a steering wheel, clutch and brake and all these type of manual controls to the driver. It will be completely with the hands of software brains and of course, advanced explainable artificial intelligence. So you can see that these type of controls will be able to take up every control to the data center, whether it is your body control, chassis, the Wi-Fi connectivity, GPS sensors, rear arms, rear head arms, or even the headset units. So now everybody, I will be discussing about what type of enabling technologies will be there that is actually required to be researched out so that you can make this type of ecosystem possible. And let me tell you, very important, like Tesla, Waymo, Apple, if you talk of General Motors, Hyundai, Honda, Siemens, they are all working together and even autonomous bikes are possible right now. Autonomous cycles have been developed. Autonomous cars are being developed, but the only thing is that the testing of those cars require more time, so that the safety and precaution and of course the privacy of data will become very important for them. So that's the reason in Korea lots of dummy smart city based farms are being designed, and lots of companies are practically researching on their live algorithms on smart cars, so that when they implement it should have 100% perfection in execution. So in order to make that possible, there are plethora of convergence of technologies that work together. So some of them are like security, fog computing, connectivity, and of course ad hoc networking. And of course, recently we have started working on named space networking. So in this lecture, I will be just covering 3 or 4 base technologies, and after that you can ask me questions that what exactly we are working and what exactly is our vision for the near future in next 2 years. So in terms of security, I've already told you that at the start, we have started with IDS systems and honeypots, but now we are replacing it from car to the cloud with blockchain technology. So this is one of the good area that you can do your research. And of course, with the vehicle to vehicle and vehicle to infrastructure, and of course, in terms of maintaining the authentication and authorization, we can only trust blockchain as a security-based measurement. So now we can say of fog computing, which is known as a highly virtualized, secure, and network integrated computing, which is having applicability towards multi-tenancy. And of course, it is providing tons of services. And even in the near future, we can say with cloud computing, one more feature will come, like you can say mobility as a service or automation as a service. So don't think that cloud computing is just like a storage system or moving up your companies towards servers. Consider it as an opportunity. And if you really want to harness that opportunity in 2021, consider that rather than putting the data, let's move towards cloud and how we can hyperscale our complex operations in order to perform reality-based solutions to real-time applications. And that can be possible where if you talk of AWS, Azure, GCP, Bluemix, these things are becoming possible, and fog computing is the only answer that needs to be applied in this ecosystem, so that when the car generates the data and the data is regularly going in the form of live feeds by cameras, and the cloud computing based servers can give the detection of pedestrians and other things, the car is making a hyperscaler massive scale decisions for perfection driving. So this is one of the architecture that you can see, that all the car's data is connected to 5G, and it's like a fog-based server. After that, we have a massive complex connectivity using MPLS and routers, and at the final thing, we have the video servers at the cloud. So in the near future, if you ask me which cloud computing service provider will be the reliable service provider, I would not like to bet on Amazon or even Google. I would like to bet upon IBM. And of course, I would like to bet upon Oracle. So these companies have better and even more advanced complex infrastructure as compared to these companies. No doubt Amazon is leading the game, but still we are talking of complex operations in real time that requires hyperscale connectivity. So for that, we need to understand that IBM is one of the forerunner players that is required to be tested out for these type of activities. And you can see right now the seamless and optimized connectivity and mobility. So in the near future, we can only test on 5G, and we can have the live video feeds like in terms of Netflix, Hotstar, Disney Plus, and we can even make Skype calls. But the most important thing is that if you talk of the massive connectivity, then only thing we can talk of like 5G NVR millimeter waves with a loss rate of less than 10 raised to power -9. Otherwise, we can have some throughput delays or packet delivery ratio problems that can be very harmful for safety in driving. So remember everybody that this looks like a good infrastructure, but if you talk of the city planning, we need to be very careful because connectivity is everything. So this is one of the architecture that you can see with Lisp. And if you really want to research on Lisp, you can see one of my papers. And we are talking of 5G, but right now we are talking with 4G plus over here. And the results are not very good, but still we are getting the results based on research, which is quite impressive right now. But still we are talking of 5G and 6G that maybe by 2024, they become common, and we will be able to test these live infrastructures and algorithms in the real time. So this is one of the things that you can see in terms of fog service insertion when the cloud is producing the video applications, the data centers, and of course we have the layer 3 based virtualization where the advanced services on cloud and you can say wireless connectivity or automation as a service. So this is going to be another thing for all of you. Yeah, this is the one I would like to discuss. So right now, Japan, South Korea, and even USA is testing for autonomous vehicles. And for that, they are only talking of IEEE 802.11p. And that will be there because it will be like a dynamic scalable environment because at the back end, we have the fixed infrastructure. So you can say that vehicle to vehicle, vehicle to infrastructure, vehicle to anything V2X will be possible with this type of multi-hop communications. Okay. So this is one of the architectures that you can see. I have taken it from Persistent Systems based website. And you can see that in the near future, how we can have the advanced connectivity like unmanned ground robots, mobile devices, UAVs, manned aircrafts, internet, sensor gateways, radio over IP. So this all looks like in the near future, we all will work on radio communications that is totally secure. And of course, they will be they will be having convergence and collaborative ad hoc network. So last but not the least, I would like to discuss about deterministic networking. So this is required for industrial automation, building automation, robotics, and of course, they have the key elements in terms of synchronization, timely transmission, centralized scheduling, and it is like a NP-hard problem that we are solving. And it is also providing the 802.15.4 for low rate at 4 hertz, and over Wi-Fi we are having 802.11 AC. But in the near future, we can even expect 802.11 AE to be working under the required infrastructure of deterministic networking. So right now you can see that how we are moving towards determinism. And right now you can see that we are over here, that is unmanned, that is half duplex, but now we don't use it. We started from 10 Mbps and it is becoming managed. And some people and some enterprise networks are using managed connectivity. But right now, if you talk of real time, when we talk of real research, when we talk of real time streaming of Netflix, real-time streaming of robotics, and of course transportation, we are talking of somewhat like 802.11n, especially with LoRa communication. But if you talk of the future, it will be time synchronization. So even I'm working on LoRaWAN. You can see my research paper has come today only with PRJ. So we are inventing our own standardized technology that how the LoRaWAN communication can be taking a new place for transportation. Even we got an Australian patent, and now we are applying that LoRa communication towards unmanned aerial drones, and like to see the speed that how we are able to communicate with real-time object detection and video recordings. Okay. So you can see that in the futuristic deterministic networking architecture, these will be the control rooms at the enterprise level. And in the real time, we will have our industrial monitoring, agriculture monitoring, IOVs, everything. So the conclusion can be that there will be that this is a time for exciting developments. And of course, we can see profound impacts at human, social, and environmental needs. And new services will take place as soon as possible. So if you want a real-time collaborations and research collaborations, you can even write an email to me. I'm actually connected to tons of the companies which are even providing me some sensors and even with embedded systems like NVIDIA. And we are testing with Python and of course with OpenCV that how we can make these autonomous vehicles better with artificial intelligence. Thank you so much. And now the house is open for next 10 minutes for your questions.
Thank you, sir. Thank you very much for sharing wide knowledge about future transport systems, sir. Sir, I have a question here that what are the opportunities EC student will have with this technology, sir? And one more thing is what are the tools to be developed to learn these technologies?
Sure. I would like to give you the first answer that what opportunity. Can you please mute yourself, ma'am? So I would like to give you the answer that as you can see that in terms of opportunities, not only ECE, but CSE, mechatronics students are even having tons of opportunities that EC students can work on sensors and even they can work on autonomous capabilities. They can work with computer science people to develop the artificial intelligence brains. So This type of things require tons of massive scale connectivity in terms of sensors, lidar, of course, radar, you can say of assistive technologies. So EC students will be taking a good mark, and they can learn on like circuit design. They can work with artificial intelligence. They can work with Python, data science. Everything is connected there. Now, coming to the tools, madam, for autonomous vehicles, even I'm working on autonomous vehicles right now. So we are working on cloud computing, blockchain. We are using Python, OpenCV. Even we have collaboration. Even I have a collaboration with NVIDIA. So they have sent me NVIDIA Jetson Nano, and over there we have installed their NVIDIA, that is the smart driving based SDKs, and we are working on detection of live pedestrians and other things. So that is what we are doing. So even the EC students can even use embedded systems. They can design their own remote control cars, and with Raspberry Pi and with Python and with their advanced motion sensitive cameras, they can work on tons of projects like this. So it is all sensors, electronics, circuit design, and many other opportunities are available depending on what type of you can say application area and the functionality area they want to work.
Yes, sir. Sure, sir. We will transfer the same or impart the same to the students and will inform them, sir. Thank you, sir. Uh, one more question is here, sir. Any concepts you suggest to incorporate in curriculum so that we are already for such industry-based projects?
Sure. Madam, for if you really want to the students to work in this, so I would like to tell you that please add the concept of circuit design. You can even add the concept of embedded systems with Raspberry Pi, NVIDIA Jetson Nano. You can add Python with OpenCV. So if you are learning these type of technologies, you can make small applications to medium applications that can be applied to the futuristic autonomous vehicles.
Yes, sir. Yes, sir. Thank you, sir. Thank you for your question and answer. Participants, any questions here? Sir, one more question I'm asking, sir. What does IoT means for the future workspace?
Madam, IoT is everything. If you talk of Internet of Things, we can implement in smart cities. We are implementing in buildings. We are implementing in agriculture. It is not the one thing that IoT is going to take up. It is actually the futuristic shape for the mankind. So if you talk of today's like autonomous vehicles, if you talk of drones, if you talk of environmental monitoring, industrial monitoring, and if you talk of like smart parking systems, autonomous shopping malls, IoT is everything, man. You can put IoT even to your smart homes, to vehicles. It is endless.
Yes, sir. Yes, sir. Sir, thank you, sir. Thank you for answering questions. Sir, now I would like to summarize your talk, sir. So, uh, future transport systems, you have started with the customized internet and architecture for dynamic environments, sir. And then LoRa, for internet connections, we should have the more internet connectivity like LoRa and 5G, even 6G. That is possible only, as you said, it is from 2024. But we are working on that. I know that, sir. Thank you. And then computing power. To enhance the computing power, we need quantum computers. So
Yes.
supercomputers and quantum computers. And one more thing is common IoE interface architecture. And you have discussed about embedded system and artificial functionality, big data, cloud, and fog and edge computing, sir. And then for network issues, so we need to have the more advanced routers, security, sir. And then for vehicle to vehicle communication and transportation, we should have the swarm sensors and super connectivity with the super sensors like ladder and radar, like this, sir. And then you have talked about autonomous cars, bikes, and cycles that we are going to see in future. And you discussed about fog computing and Lisp mobility and architecture and deterministic networking, sir. Thank you very much, sir, for enlightening us with your knowledge and for the latest topic. Thank you. Thank you. Sir, one more thing, sir. Madam, yeah, you continue.
sir. Thank you very much, Dr. Nair, sir. And I have been fortunate enough to listen to a number of your lectures during the FDPs. Very informative and a lot of knowledge and a lot of technologies that you discuss on. And today's session, it was a very comprehensive discussion, sir, on smart transport system. Thank you so much, sir, for spending so much time with us. And definitely, we would like to have maybe a few student trainees, something like that. Maybe we could look at that. And definitely, we would like to be associated with the university, sir.
Sure, sure. Please write an email to me. We will see what the best can be possible as soon as possible.
Sure, sir. Sure, sir. Actually, last July or August, I had contacted you regarding setting up of IoT in our college. And it was like almost a year ago, and I couldn't actually work on that. But definitely, I would look into it this year
We can have some
because
meeting
of.
maybe next week, and I can guide you what is to be done and what kind of equipments you need to buy and how you can set it up in the right direction. I will help you for that.
Sure, sure. Thank you so much, sir. I appreciate that. And we now wholeheartedly welcome you to please continue to be with us. We have the valedictory function in a few minutes. So
Sure,
please, sir, please accept our invitation, sir.
sure. I'm
And
there.
you'll be there, sir. Thank you. Thank you so much, sir. And a token of appreciation will be sent to your email, sir, shortly
Sure.
from the team. Thank you so much, sir.
Thank you.
And now, and now, sir, just give us a few minutes, sir, for us to set up the system. Thank you,
Yes.
sir. Thank you.
చేసుకోవచ్చు పెట్టమని
A very warm good afternoon to everyone present here. I take this opportunity in inviting everyone to the valedictory ceremony of the Applied Mathematics, Modeling and Simulation in Engineering AMSE 2021. I'm Nasreen Sultana from Department of Humanities and Sciences. I'm elated to share that Stanley has received an overwhelming response from the participants across the globe and successful keynote sessions. I take pleasure in inviting the guests onto the dais. I request Dr. A. Vinay Babu Garu, Dean Academics, Stanley College of Engineering and Technology for Women, to grace the dais. Thank you, sir. Now, I take extreme pleasure in inviting the convener AMSC 2021, Dr. B.P. Ramanmurthy Garu, Vice Principal, Stanley College of Engineering and Technology. Thank you, sir. Now, with equal pleasure, I invite the convener AMSC 2021, Dr. Nagashekar Reddy, HOD, Treasury Department. Thank you, sir. Now, I'm equally happy to invite the conference chair of AMSE 2021, Dr. Y.B.S.S. Pragati, who is also the head of the Department of Education. Thank you, ma'am. Last but not the least, I take pleasure in inviting the principal of Stanley College of Engineering and Technology for Women, Dr. Satya Prasad. I also invite our virtual guests who are present. The guest of honor, Dr. Dak Mong Lee, Professor of Computer Science, Deputy Head of the Faculty of Information Technology, Hai Phong University, Vietnam. I also invite our guest of honor, Yu Jin Bo, Dean of CCNU Wollongong Joint Institute, Deputy Director of National Engineering Research Center for E-Learning at Central China Normal University, Wuhan, China. I'm honored to invite our chief guest for today, Dr. Sujata Shahi, Professor of Organizational Behavior and Human Resource. I welcome you all to this valedictory program. Now we have a conference report presented by Dr. P.R. Anisha, member of the editorial board. There's a delay. I request Dr. Ramanmurthy sir to continue with the proceedings.
A very good afternoon on the dais, dignitaries of the dais, offline and online stakeholders. It's a privilege to give the report on the conference. We have started in the month of February 2021. It's been 7 months. Over the 7 months, the Stanlians are working for this one, which is led by Dr. Kishore Kumar Reddy and Dr. Pragati. They have spearheaded this particular movement, supported by principal, management, and dean. There were some places where we will look for. It's like a place, some place look for a beautiful place. Some people look for a beautiful place, others make a beautiful. This place has been beautiful. So all the researchers, all the stakeholders, the session chairs, keynote addresses has made this particular Stanley a place of knowledge over the past four days. And for this, we are working for day and night for our last 7 months. The conference report which I am going to give, the facts were, it is over the national, international. We have got around 475 papers since the inception from February. There were a lot of teams working for this particular AMSC 2021. 475 papers we have received. This is just a recap of the process which we were doing. 63 were accepted and 57 were presented. There were around 5 tracks and 17 keynote sessions, and each track is having a best paper award and an overall paper award, which will be declared by conference chair. So it's like a productivity over the past 4 days where researchers are exchanging their views. It's a platform of learning. I can say that by this we can share our knowledge. Stanley has become a temple of learning, and this is another feather in a cap. I will end up with the process saying the productivity. Productivity is never an accident. It is always the result of commitment to excellence, intelligent planning, and focused effort. So I can see around 475 researchers who has published or who has submitted their papers. I can see the productivity in them. All the best to them. And many research ideas might have evolved over the last 4 days. Thanks to one and all. Thank you.
Thank you, sir. Now we have a member of the editorial board, Dr. P.R. Anisha, presenting the conference report.
Hello. Hello, Nasreen. Am I audible? Hello.
Yes, we can hear you.
You're able to hear me, right?
Yes, we can hear you. Please continue.
Just give me a moment. I'll just try to again log in because I find a disturbance from the other end.
We can hear you.
Tell her that she's on mute.
You're on mute. Please unmute yourself.
Yeah. Hope I'm audible now.
Yeah, you're audible.
Good evening to one and all present with us via online and offline mode. I, Dr. P.R. Anisha, one of the editorial board member of the AMSC 2021 conference, on behalf of the organizing team, takes pleasure in presenting the AMSC 2021 conference report. The first international conference on applied mathematics, modeling, and simulation in engineering is a conference which holds its proceedings under the IOP Science publisher. The aim of the conference was to create a virtual gathering for scholars and researchers from numerous disciplines to meet up to share information, thoughts, exchange knowledge, and learn about frontline research in assorted fields. Before I present the report in detail, let me share with you that this conference, which was scheduled on the 15th and 16th September, has enlightened these 2 days of knowledge sharing festive with a pre-conference carnival from the 12th to 14th of September. We had 15 plus keynote sessions from the 2nd September, delivered by various eminent personalities from prestigious institutions and industry by creating a virtual platform of knowledge sharing. Now, proceeding with the journey of the AMSC 2021 conference. Initially, the conference was called for, and the theme of the conference was identified in the month of Jan 2021. By the month of February 2021, a theme titled Applied Mathematics and Simulation in Engineering was decided. In the process of identifying the relevant conference scope as theme decided, IOP Sciences JPCS series stood relevant. In this regard, we approached the IOP Science JPCS series for the possible conference proceedings. In the meantime, to plan up further and to take the plan into action, we have parallelly identified various committees for the conduct of the conference with an ease. Our major were our chiefs of the conference, Professor Papula Lakshmi Narayana, Registrar, Usmania University, Hyderabad, India, Professor Sujata Shahi, Vice Chancellor, IILM University, Gurugram, India. Our guest of honor for the conference, Ms. Yu Yang Fen, Asia Pacific Leader for IBM Global University Program, Singapore, Sri Chandrasekhar Buddha, Chief Coordinating Officer, AICTE, Ministry of Education, Government of India. Professor Zheng Yu, Professor and Dean, CNU, Wollongong Joint Institute, Central China Normal University, Wuhan, China. Dr. Dak Hong, Lead Associate Professor and Associate Dean, Faculty of Technology, Hai Phong University, Vietnam. We had the chief patron of the conference as Bishop M.A. Daniel Sir, Chairman Stanley, Shri Kodali Krishna Rao Sir, Secretary and Correspondent Stanley. We had our patron as Professor A. Vinay Babu, Dean Academic Stanley. The conference chair as Professor Salman Abdul Moiz from University of Hyderabad, Professor YVSS Pragati from Stanley. Our general chairs, Professor V. Anuradha, Director Stanley, and Professor Jagdish M. Rathod from BVM Engineering College. Our honorary chair, Ms. Ye Yung Feng, Global University Program Leader, IBM Singapore. Our program chair were Professor Kedarnath Sahu, Stanley, and Professor Anand Nair, Dutan University, Vietnam. We had our finance chair as Mr. Rakesh Reddy Sir, Management Member Stanley. Our convener, Professor B.V. Ramnamurthy Stanley, and Professor N. Nagashekar Reddy Stanley. The coordinators of the program, Professor Gunta Karthik from Stanley, myself, Dr. P.R. Anisha from Stanley. The editorial board members, we had Professor Satya Prasad Lanka, Principal Stanley, Dr. Kishore Kumar Reddy, Associate Professor Stanley, Dr. P.R. Anisha, Associate Professor Stanley, Professor Brojo Kishore Mishra, GIET University, and Dr. Nguyen Kian Hu, Dean Graduate School, Dutan University, Vietnam. I would like to take this opportunity to thank Professor Brojo Kishore Mishra and Dr. Nguyen for being a constant support. Their expertise in conducting 50 plus conferences across the globe was an asset to us in conducting this conference. They were with us right from day one, that is, from the day when we called for the conference. They were associated with us, who has helped us out in how to trace, how to draw the line towards making this conference a successful part. Without their support, we do not think so that this conference would have stand up to this level. We had our organizing chair as Professor A. Gopal Sharma Stanley, Professor B. Srinivasu Stanley, Professor K. Ramakrishna Stanley, Professor M. Kezia Joseph Stanley, Professor A. Kanakadurga Stanley, Professor Y. Padma Stanley. In the month of April 2021, we have moved ahead with a call for paper upon receiving the final approval from IOP Sciences. The website committee chaired by Professor Narendra Reddy and team designed the website and was the one that created the actual feel of the conference with all the conference information and timely updates on the website. The publicity committee chaired by Professor B. Anuradha, along with the team, put forth a tremendous effort in circulating and publicizing about the conference globally. And this has been an asset to us in showcasing about a conference worldwide. Parallelly, the Technical Program Committee, chaired by Professor YVSS Pragati, and her team identified the reviewers, and around 123 reviewers with well academic and industrial experience were selected globally. Meanwhile, the corresponding editor, Dr. C. Kishore Kumar Reddy, worked towards framing the advisory board for the conference. Around 103 advisory board members representing top notch institutions, industries, and renowned researchers were identified. We have received around 475 papers from various parts of the globe. To name a few, we received papers from USA, Vietnam, Bulgaria, Romania, Egypt, Australia, Malaysia, Canada, Spain, and many more. Within India, besides receiving papers from private universities, we also receive papers from top-notch universities and industries. To name a few, we had papers from IIT Hyderabad, IIT Kharagpur, IIC Bangalore, IIT Madras, NIT Shiv, Delhi Technological University, IBM, Accenture, Siant, and many more to frame ahead. The review committee headed by Professor K. Vaidehi, along with a team, carried out the task of reviewing the papers. Among the 475 papers received, only 62 papers were given acceptance, of which 57 papers were registered, keeping the overall conference acceptance rate of just 12%. This was to raise up the standard and to maintain the standards given by the publisher. Further, the editorial team divided the conference into 5 tracks headed by 10 session chairs coordinated by Ms. M. Saumya. The tracks were Advances in Engineering, handled by the track in charge Ms. Shivani Yadav, Computation Intelligence, handled by the track in charge Ms. Vailata, Applied Mathematics, handled by the track in charge Ms. K. Nagamani, IoT and Cloud Computing, handled by the track in charge Ms. P. Pallavi, Industry 4.0, handled by the track in charge Ms. T. Nagalakshmi. As the conference touches various disciplines based on which the tracks are framed, we have made sure to select the best paper for each of the track and also have planned to certify them. In the meantime, we have selected the best paper for the overall conference and shall certify the same as well. There were around 17 keynote sessions addressing major cutting edge industrial technologies and needs during the 12th to 16th September, for which around 284 participants have registered across the globe, and this entire task was taken up by Ms. Udayani Chandana and Ms. T. Prasanna. The Infrastructure Committee, chaired by Professor R. Manivanan, along with his team, took up the task of making all the technical arrangements for the entire pre-conference and conference conduction. To showcase the updates of the conference in the print media and press, we had huge support from R. Suresh Reddy sir, who on time made sure that the conference updates were in the press in time on a daily basis. Our supervisor, Web Srinivas sir, has rendered all the possible support in terms of arrangements and services in all possible manner. The technical team, L. Fani Kishore sir, Jabbar, Krishna Kumar, and Giri, has worked all through along to successfully conduct this online conference. I must say that the complete Stanley fraternity worked day and night in all possible manner, either virtually or offline mode, even on holidays, for the conduction of this conference without any excuse and without any hindrance. Our digital marketing team, headed by Ms. Shruti, along with her team, helped us in designing all the conference posters, banners, flyers, which was a big impact on our digital platform in reaching the masses. I, on behalf of the management, administration, organizing team, thank each of them wholeheartedly for giving your best out of to conduct this conference, without whose support this conference wouldn't have reached the place where it stands today. A very big thank you to each one of you. For the future plan, we, as we have conducted this conference on the 15th of September, on the eve of Engineers Day, we would make sure that the coming 15th of September we from Stanley would come back again with a next conference too. With this, I would try to give it up to Nasreen ma'am to take up the proceedings further. Thank you.
Thank you, Alisha. Thank you for a very detailed report. Now, I request Dr. Satya Prasad Ganka, Principal Stanley, to address the gathering.
Distinguished chief guest of honor, respected Dean, Academics, Dr. Vinay Babu, Conference Chair, YVS Pragati Madam, conveners of the conference, Ramamurthy Garu, and Nagashekar Reddy Garu, General Chair for the conference, V. N. Rodha Madam, and organizing committee members, colleagues, friends, presenting authors, and delegates. I am very glad to be here at the concluding session of the conference AMSC. And once again, I am very proud that though you see among the dais, predominantly men, this conference is a celebration of woman power at Stanley. I'm very glad that another statistics has been brought to my notice that out of the 57 papers which were presented, 34 papers are having women authors in them, which keeps in line with the motto of Stanley, empower women, enrich the world. This conference has been a Herculean task which has been well taken up by our team of youngsters. They have done an excellent job in maintaining the quality of paper publication. I have gone through some of the papers and I found them to be of cutting edge technology, really the need of the hour. But I have some comments to make about the technologies which are being favored. Currently, lots of research work is being reported, including in this conference, about federated clouds, IT automation, including IoT, business process management, analytics, and AI, including machine learning and deep learning. But the core questions related to improvement of the existing infrastructure or speed, in terms of speed, size, storage, these questions researchers are still not reporting enough work on them. This is an open question. It is like we are exploring the universe without exploring the depth of the ocean of the world. Our own world, the depths of the ocean are yet to be explored, but we are going out and exploring the universe. Like that, data management is a key issue which will speed up the process itself. Any program, speed will be improved if we improve upon how we are managing data. Unified communications, unified storage is another challenge. We are having different formats for transmission of different types of information, which is a web page. We have a certain format, www. We got a file transfer, FTP protocol, different images we transfer in a different way. Why can't we have a unified transfer? Then the 4G itself will look like 5G. We need not go for 5G technologies if we are able to do that in an effective manner and come upon a unified communications strategy. The reason for this is We are just like the experience has been that we first made the black and white TV and then we made color TV to be compatible to black and white TV, not color TV by itself. A separate unique standard was not evolved for color TV, though it was a new technology. It was made compatible with the existing black and white TVs, so it was slowed down. Instead of only RGB, you had the I and U signals also generated in the color TV, bringing its speed down. The same thing is happening to all of our communications. To keep the past communication network intact and still communicate on that, we are sacrificing on future speeds. Is it possible to speed up this process? Is one challenge all you researchers have in front of you. Another is unified storage. We have a unified clients now. Our mobile phone is doing everything. It is acting as a phone, it is acting as our projector, it is acting as our torch. You name it, it is acting as a unified client. We have a unified client, but do we have unified storage, unified presentation? For each type of information we seek from the unified client, we are having different applications. For to view a PDF, we have one application. To view a doc, we have another application. To view a image, one application. Why? Why are we going on a single application which will render all types of information? For each mind type, why do we have a different application? This is bringing the cost of the, which is going to bring the cost of the client down. It's going to make the client sleeker, faster, and better. Anyway, these challenges of the future are what we must be investigating before we investigate new ways to use the internet to communicate more, to transmit new types of information. The challenges must be accepted, and I throw this question open to all the researchers who are listening in for this conference. This conference has been raising interviewing questions. When I listen to some of the sessions live or in recording format, I found very novel approaches, especially with social awareness. Social engineering is concerned. The experiences, the reportage, including how to utilize or gain more for every penny invested. Such type of reporting also, awareness is coming. They were the highlights. It was a really eye-opener to many social engineering projects taken up and reported in this. And glad that youth is investing so much time in this area over here. I'm very glad that Stanley is at the forefront of not only disseminating information, but also generating information with the vast amount of researchers we have. We have 30 and odd already PhD holders, another 35 plus young researchers who are trying to acquire their PhD through research. And we have a very active research center here, which is empowering these young people over here. And I'm very glad that most of these young people I am citing are women. Thank you very much. All the best in keeping with this. Come Engineers Day, as Alisa said, we will meet again. Before that, we will meet on Women's Day for the Women's National Conference, which is another periodic event of Stanley. So your next paper publication do plan for the Women's Day in 2022. All the best. God bless you.
Thank you, sir. Thank you very much. Now, I would request our virtual guest, a guest of honor, Yu Xing Guo, Dean of CCNU Wollongong Joint Institute, Deputy Director of National Engineering Research Center for E-Learning at Central China Normal University, Wuhan, China, to address the gathering. I take extreme pleasure in inviting Professor Yu Sing Go, who is the Dean of CCNU Wollongong Joint Institute and the Deputy Director of National Engineering Research Center for E-Learning at Central China Normal University, senior member of both IEEE and ACN, and an adjunct professor of University of Wollongong, Australia. He is a member of steering board of PSI-PT Conference and a member of steering board of Smart Educational Technology Branch Society under Automation Society China. He received his PhD degree in computer science from National University of Singapore. His current research mainly focuses on intelligent educational technology, educational robotics, multimedia analysis, computer vision, machine learning, artificial intelligence, and virtual reality. He has published over 100 research papers. He is an associate editor and guest editor of several international journals. He was agenda chair and program chair for more than 10 international conferences and served as currently a conference chair of IEEE International Conference on Engineering, Technology and Education 2021. I welcome you, sir.
Okay, thank you. Thank you. So yes, then thank you for your introduction. Nice introduction. I'm glad to know you have the my peer researchers in the country have hosted this international conference on applied mathematics, modeling, and simulation in engineering. This is the research areas I'm interested in. So I'm glad to be join this conference. I have glanced the papers registered for this conference. I found they are most of about the intelligent the living and transportation and some things. I found the research intelligent education. This is a kind is my research areas is have the less the paper in this conference. So I introduce some the research in these areas to share to discuss with you how this research can be do research further. Okay. So intelligent education technology, we are working in this area for longer than 10 years. For the 10 years, our faculty have more than 200 faculties. Okay, it's very big because our faculty include the four schools. 4 schools. It's not just only one school, it's 4 schools. So it's very big. And we are most largest team in the whole China to do the intelligent education technology. Our mission of research on the educational technology is to innovate new technology and integrate the technology, especially intelligent technology, to promote our education. Okay. We are in China. This area is very activities and achieve quite significant progress. Now in China, most of the university and the high school, even primary school, they have used on the educational cloud. They support their education for, especially for some of them, extra courses. Okay. So in this way, education intelligent to develop intelligent education. We have what kind of technology support this kind of reforming? What kind of technology reforming our education? We are through the research found ABCD technology. That is the most technology, most activities technology to build the intelligent education. A represents the artificial intelligence. B represents the blockchain, C represents the cloud, D is data. So A, B, C, D. Okay, and we found that A, B, C, D have their own roles to make progress for the intelligent education. For A, artificial intelligence can fulfill educational routine jobs. All the education is the intelligent job. It is the cognitive activities, the thinking activities, reasoning activities. But some of this kind of activities are routine. Some is then creative. You need a human being to figure out the method, the way to solve some problem, and the current on the site. But most of this kind of job is routine job, like grading, reading, and some so on. Okay, like the evaluate how good is the performance of the students. All these kind of things have the intelligence, have them the human intelligence. But this kind of human intelligence is a routine job, can be conducted by the artificial intelligence technology. Is at least at some degree. Okay. Another one is blockchain. Blockchain is the safety, then provided a new technology to make the security and reliability, especially for the education. It's not highly security, but they need some fair the exchange of the education and fair market for the education. And this kind of education, the market, we cannot invest too much money on the security. So blockchain can provide this kind of service that have low cost and can make our market on the intelligent education is healthy. Okay. The cloud is quite a popular technology for the educational technology now in the education, because the cloud provided is the platform make the students and the teachers, students, the parents can access the cloud to get the educational materials, get courses, get support very easily, very low cost, and very time efficient. Means that it's very quick, and also is very new materials, because the new things to deliver through the cloud can be whole country can be happen at the same time. Okay, that is the cloud. So for this, then ABCD data is a lot of things. Data to provide us to evaluate all the student performance, education performance, and the knowledge. All these kinds of things can be through the data to do the very accurate calculation, computing, to find out very accurate the result. How good are students? What are the knowledge the students have mastered, and what are the missing point? All these kinds of things. ABCD. Okay. So this is one thing. A lot of things in the support educations. We have the education cloud. On the education cloud, we need to service a lot of the students and the parents. We need a lot of tools. Okay, the teaching tools, experiment tools, and calculation tools, presenter tools. All these kinds of things we provide on the education cloud. And this kind of cloud can be very cheap. Government can buy this kind of technology and to serve all the students free. Okay, A lot of things is for this kind of platform and systems for the special students, especially for autism. Okay, because the autism students, they can communicate, interact with them computer systems or intelligent learning system without any problems, but they have the problem to interact with them human beings. So develop this kind of system help them a lot, help their family a lot. Okay. And then our cloud platform also provide a lot of very beautiful teaching materials, because the virtual reality technology can draw very beautiful and create a lot of very beautiful educational materials and figures. Okay. So also we do a lot of, this is most of this kind of things I have talked, we are applying the intelligent technology into the education. But our education also have appeared some of the artificial intelligence power, like how to solve the exercise problem by algorithms. This kind of problem called problem solving. Problem solving is education artificial intelligence problem, but it appear from them come from the education. Is the one. Another one is then how to do the use the intelligent algorithm to do the diagnosis, to test, to find out how good the student's performance. This is another artificial intelligence problems from the education. We have done a lot of the fundamental research on this kind of problems, okay, and achieved quite significant progress. I found in the whole world they have several teams work on this one, from the US, even from India and Japan, and so on. Okay, this is the I think a lot of trends about this then artificial intelligence on education. Maybe is the educational robots. Educational robots can be integrate a lot of artificial intelligence to help the students to improve, enhance our education. So this is a lot of topic. This is my sharing, and I don't talk about the details about these things. This is my just share some of the idea and topic idea with our dear peer researchers in the conference. Thank you.
And resource for the wisdom of advice. Our virtual guest of honor, Dr. Dak Nguyen Lee, Professor of Computer Science, Deputy Head of Faculty of Information Technology, Vietnam, is unable to join us because of a technical problem. Thank you, sir, for being there despite this. I now invite our virtual chief guest, Dr. Sujata Shahi, Professor of Organizational Behavior and Human Resource, to address the gathering. Dr. Sujata Shahi is a professor of organizational behavior and human resource. She has an experience of over 3 decades and has been teaching and handling administrative responsibilities at IILM Gurgaon for the past 15 years. She has keen interest in analyzing the behavioral aspects of employees in organizations and has published various research papers in this area. She has worked on research papers like consumer behavior, perception about retail sector, corporate social responsibility, innovation, manpower management, mindfulness, and emotional intelligence. She has conducted management development training programs for corporate executives coming from public and private organizations like Alcatel, BHEL, EIL, PhD, CCI, CII, Defense, Military Engineering Services, TI, to name a few. She is a member of professional bodies like National Human Resource Development, Higher Education Committee, Confederation of Indian Industry, editor of MBA Journals Consortium E-Learning Network, Indian Society of Training and Development, AIMS International, and a member of Executive Council and Board of Studies of different universities. I welcome you, ma'am.
She's on mute.
Ma'am, you're on mute. Please unmute yourself.
So thank you and good evening everyone. Namaskaram to all of you. Shri K. Krishna Rao, Professor Chandrasekhar Buddha, Dr. Yu, Dean Central China Normal University, Dr. Lee, Associate Dean Hengpong University, Professor Pragati, present dignitaries, faculty members and scholars. First of all, I would like to thank the organizers of the conference for giving me the opportunity to share my thoughts. Just to start with, what do you think the reaction of Captain America would be if he woke up after being frozen in ice for 75 years and attended these lectures in the last 2 days? I can only relate with one quote from Arthur C. Clarke for Steve Rogers. Quote, any sufficiently advanced technology is indistinguishable from magic, unquote. The way I heard from all of you, the kind of tracks and everything, is amazing. Integration of technology in every facet of our lives can be felt inevitably. We can perceive and understand its role all around us, even more after the pandemic. That is why I wanted to share my understanding on the role of technology in the future of education and take this opportunity to learn from all of you. Alexa, Siri, Google Assistants are the major examples of virtual assistant services, while automated bots answering the questions of customers are the example of artificial intelligence based chatbots working with best performance. Just before me, Professor has mentioned about blockchain to artificial intelligence, the relevance of these technological based functioning across the world going to be very, very important. And right now we don't know what kind of jobs are coming in near future, but still we need to prepare our students on the base of technology integrated courses. This is the only way out for us. And today, the amount of data that is generated by both humans and machines far outpaces humans' ability to absorb, interpret, and make complex decisions based on the data. And the only way out we are looking for, that is technology. Also a system that is based on the technology-driven arrangements fulfilling the dreams of the 21st century, not the policy of the past century. I may not be speaking for all the attendees of these amazing last 2 days, but I'm definitely speaking for myself, what I learned since last 15 to 20 minutes, which was hearing from all eminent speakers and organizers. I think last 2 days have been absolutely magical for everyone. What has been covered in the sessions like IoT, cloud computing, computational intelligence, these are like upcoming areas and which has been covered in these sessions planned over these days have been phenomenally insightful. Computational intelligence, IoT, and cloud computing, these are the words that are going to be part of corporate culture in the times to come. This thereby would be embedded in the DNA of the educational institutes, which prepare future leaders for this work. I would like to share that being a liberal art university, ILM offers certain courses which integrates human thinking with machine to our students. I can give you some example about mind and machine, digital humanities. These are certain examples. And I can tell you, like you talked about cloud computing and you are part of the technical college, science and technology. But being a liberal art university, what we provide, we integrated technology in every facet of campus life. Like I said, mind and machine. What digital humanities say? We all do reading at computer. In such situations, computer replaces the printed books. Even during pandemic, we all referred our students e-books. What could we discover if we read a text published in the early 18th or 19th centuries? Does this bring any change in reading and understanding of a novel? If we let it out in geographical space, digital humanities course help us explore the above questions. The old age books now available in a digital forms. The course which we design examines the contrast and continuities between traditional and digital humanities, role of digital archives, and the tools and techniques used by digital humanists. Similarly, mind and machine. It focuses on our current understanding of human thinking, both illuminated and challenged by the evolving techniques and ideas of artificial intelligence and computer science. Also examine fundamental issues at the intersection of philosophy of mind, cognitive science, and artificial intelligence. The synergistic combination of cognitive science, neurobiology, engineering, mathematics, and computer science holds the promises to build much more robust and sophisticated algorithms implemented in intelligent machines. As you know, IoT has transformed our understanding of connected things, defined by the machine to human, and technology assisted people to people communications. It has created unprecedented opportunities for organizations, individuals, communities, and countries to realize dramatically greater value from networked connections. We are surrounded by these technologies everywhere. Every new application has a scope for both of these. So, as the future of technology, we need to have a thorough understanding of these technologies so that we can build on top of what is existing and we can prepare engineers who can work and provide world-class technical solutions for those unsolved problems. One thing also I would like to highlight here, our national education policy. What NEP says? NEP defines integration of STEM with humanities and liberal arts. Why? Because beyond learning across a broad range of disciplines, a hallmark of liberal arts education, mastering interpersonal competencies from resilience, persistence to communication and teamwork, which is imperative. Whether you study science, humanities, or the arts, an education imbued with high quality liberal learning or multidisciplinary learning will lead to lifelong learning and deep last understanding. That is the best possible preparation for work. I think we have to move from science, technology, engineering, mathematics to science, technology, engineering, arts, and mathematics. Just we need to add one word, one alphabet, art. STEM to STEAM, we have to move. That will give greater value to our future students and future leaders. We have a responsibility to transcend traditional disciplinary limitations in pursuit of intellectual fusion and develop a culture of academic enterprise and knowledge entrepreneurship. I have one request, because I know the kind of research papers you all have received, then shortlisted. Finally, 57 papers were presented. And I think more than 275 people attended the 2 days conference with intellectual outputs. I have one request from all the researchers, presenters, and dignitaries who are present here. Mental health is one of the pressing issues in our current time. Poor mental health takes a heavy toll on individuals and business. New digital solutions can help employers provide personalized support and make well-being a strategic focus for their organizations. What is true about the use of technology and mental health today? Companies and individuals are creating apps that are designed to help people track their changing moods and thoughts, increase positive mood, and relax. So I would be really glad if you can start researching and create a solution using all the advances in technology on mental well-being. This is the demand of hour. It will definitely pave the way for an India which will truly be healthy and prosperous. Without taking much of your time, thank you, Stanley College of Engineering and Technology for Women, for creating this wonderful platform to brainstorm on the advanced approaches of technological aspects. I'm also feeling proud being a part of the organization who believes in inclusiveness and inclusion. Once again, thank you for giving me this opportunity to share my views and learn from others so that we could make our educational system robust, transparent, and sustainable. Lastly, I can say technology affects the way individuals communicate, learn, and think. Thank you once again for giving me this opportunity.
Thank you, ma'am. Thank you very much for highlighting the need for the system to change from STEM to STEAM. Thank you very much. As part of the valedictory program, I request Dr. A. Vinababu, Dean Academics, Stanley, for taking the honor of release of the proceedings. Thank you, sir. Thank you, everyone on the dais. Moving on to the next segment, I request Dr. Y.B.S.S. Pragati, Head of the Department CSC and Conference Chair, for the best paper announcements.
Good evening, everyone. We had 5 tracks. For each track, there is a best paper, and finally, we have one paper selected for the overall best paper award for the conference. So, the track number 1, Advances in Engineering, paper ID 60. Title of the paper, Relationships between PPP projects and SGDP in Indian road sector. That's the best paper for the track 1. Track 2, Computational Intelligence. Track 2, Computational Intelligence, paper ID 406, a hybrid microprocessor scheduler for soft real-time systems with processor affinity concept. Track 3, Applied Mathematics, paper ID 472, a text mining using web scraping for meaningful insights. Track 4, IoT and Cloud Computing, paper ID 409, uplink and downlink variation in drone technology for cloud, edge, fog, and smart demonstrations over WSNs. And finally, the track 5, Industrial 4.0, Industry 4.0, paper ID 265, performance analysis of biomass energy using machine and deep learning approaches. So these are the best papers for the individual tracks, and the overall best paper award for the conference is given to the track number 2, Computational Intelligence 406, hybrid microprocessor scheduler for soft real-time systems with processor affinity concept. Congratulations to all the best paper award winners, and I also congratulate all the people who have successfully presented their papers in the different tracks. Thank you.
Thank you, ma'am. Now it's the time for release of the brochure for the next academic year. I invite all the star women of Stanley for this. I request Pragati ma'am and Anuradha ma'am to take the initiative. I request all the other ladies of the dais to come forward.
నాకు ఎంతమంది పేర్లు తెలుసా అనిపిస్తున్నారా?
I request Raman sir also to join. Thank you, everyone.
Jabbar, turn the camera. That's okay.
I request Dr. Shekhar, Head of the Department EEE and convener of the program, to propose a vote of thanks.
Before I present vote of thanks, I would like to congratulate all the participants of the conference and the best award paper recipients. So once again, congratulations to all. So as all you know that September 15 and 16, so we have organized one conference, first international conference on applied mathematics, modeling, simulation engineering. So that is just 2 days conference. But background work is nearly started 7 months ago. Really. So we all see that only these 2 days only, okay, one big band is hanging, okay, something is going on in the college, so conference is going on. But background work is very hard. Okay. Just that will not come in just 2 days or 3 days. Nearly that was started in the month of February 2021. So thanks to the entire team. So now I started to vote of thanks. The entire team is divided into 3 categories. Number 1 team is wisdom category. Number 2 is overseeing category. Number 3 is obeying category. So wisdom category, coming to the wisdom category, for example, in order to organize any international conference like such kind of these conferences, always instructions, wisdom, and the sessions, lot of things are required. So that team is really our beloved Dean Academics, Dr. A. Babu sir, and beloved principal, always they are at the back and they are running us. Thank you, sir. Thank you very much. And, like such kind of wisdom and knowledge and instructions. Without that wisdom, knowledge, instructions, not possible to conduct these kind of conferences. So that is the first one. Coming to the second one, overseeing team. You know, so Madam Conference Chair, Dr. Y.V. S.S. Parthi Madam, and convener. So myself convener, but total burden was taken by Dr. Ramanmurthy sir, nearly. Sir made my work very special. Thank you, sir. And you know, as long as conference is going on, wherever is it, okay, Kishore sir, here, there, everywhere Kishore sir is. I mean, I was watching on this, so that means overseeing team is very, very important, monitoring all the things. Okay, live is running or not, live is coming or not, okay, everything is okay. Okay, so the conference chair and convener and Kishore sir and coordinators, Anisha madam and Karthik sir, and not only that, our beloved general secretary, Dr. V. Anuradha madam, madam is coming. Okay, so the decoration is not, everything is arranged or not, madam calling and everything. So like that, she arranged a lot of things. Thank you, madam. Thank you very much. And the obeying team, okay, just we are giving orders and do this. Not only that, all faculty, entire Stanley College obey what are the commandments given by our wisdom team and our obeying team. So thoughtfully they have done to all the departments. Okay, those really not only CSE or IT or ECS, for all, even administrative department, accounts department, the office department, for every department, to all, they have obeyed heartfully and they have made this conference very successful. Thank you once again. If I keep on telling names, entire Stanley College will come. So once again, I thank to all the students for coordinating this conference and those who are keynote speakers, you know, not only 15, 16, from 12th onwards, keynote session started. So really a lot of keynote speakers are there. Thank you, sir. Thank you for giving your valuable time and accepting our invitation and presenting your valuable lecture and valuable anything. Okay, thank you once again. And thank you. We will meet on next year. Thank you once again. And not only that, you know that this is not offline work, this is online work conference. So back at work, Dr. Manivanan sir, working with Jabbar sir and Pani sir, Giri sir, they have arranged everything. Okay, not possible to conduct online mode without having, such kind of technical thing. Thank you. And finally, last but not the least, our chief guest also. Thank you, sir, and P. Lakshmi Narayana sir, and many chief guests are there. So today's chief guest, Sujata madam also there. Thank you, madam. Thank you once again. and those who have participated and those who delivered keynotes are from international also. Thank you once again. Thank you all. We will meet you in next year. Thank you.
Thank you, sir. I request everyone on the dais and of the dais to please stand for the national anthem.
जनगणमनाधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय